Hi everybody, welcome to another video in course Algebra, section 4.4, exponential equations and logarithmic equation. In this section, we have the formula on that side. First, exponential equations. The first type of exponential equation, we use the one-to-one properties of exponents. If two things are equal, with the bases are equal, then the exponents must be equal. So pretty much we try to convert them into expression with the same basis, then the exponents must be the same. So look at the first example. 3 to the 2x minus 1 equal to 81. So 81, we can do the prime factoring for 81. 3 times 27, 3 times 9, and then 3 times 3. So 1, 2, 3, 4, 3 to the 4 power. Right? So 3 to the 2x minus 1 equal to 81, 3 to the 4 power. Now things are equal, bases are equal, exponents must be equal. So plus 1 on both sides. And then divide by 2 on both sides. Right, so the solution set is 5/2. So if we want to test the answer, it's simply just say 5/2 I've stored to x. In this case, we have 3 to the 2x minus 1. And yeah, so that's what we have. Right, next we have 25 to the 4 minus t and 1/5 to the 3t plus 1. Right, so 25 and 1/5 so look like the base is 5 in this case, so 25 is 5 squared. And 1/5 I write as 5 to the negative 1. Right, so we use these properties to rewrite 1/5 as 5 to negative 1, because by default we have 5 to the first power. Right, now just multiply. 2 times 4 is multiply the exponent together, which is this property. Right, so we have 2 times 4 minus t equal to 5, negative 1 times 3t plus 1. So multiply them out. We have, we should say that at this step, two things are equal, the bases are equal, the exponents must be equal. Now distribute the 2 times 4 is 8, 2 times negative t, and then minus 3t minus 1. Right, now try to move t on one side and 8 to the other side. Do that, we have t here, that cancel, equal to negative 9. So we check our answer. Negative 9. And one side we have 25 to the 4 minus t, and the other side is 1/5 to the power of 3t plus 1. Yeah, they're equal. By the way, this means times 10 to the 18 That means times 10 to the 3. So that's 1,000. Right. Just want to show that. Right. Next we have 4 to the 3t and then cube root of 2. So we must rewrite the cube root in a exponential form or as exponent. So here we have cube root of 2. By default, we can say 2 to the first power. And we use that property, so that property is over there, and we set the power on the top, index the radical or the root at the bottom. So here we rewrite this as 2 to the 1/3. 4 is 2 square. Now we can multiply the exponents together. 2 times 3t is 6t, and 2 to the 1/3. The bases are the same, the exponent must be the same. Here you can make a fraction and then cross multiply or multiply both sides by the common denominator. Anyway, we have 18t equal to 1 divided by 18 on both sides, so t equal to 1 over 18. Alright, 1 divided by 18 store into x, and then we have 4 to 3 times that, and then the cube root is hit math option number 4. Or we just say 2 to the 1/3. Either way, we have the same thing. Right, next we have this problem. So 8 to the 4x and then 4 to the 2x minus 3. So 8, we can say it 2 times 2 times 2 or 2 cubed. And then 4 is 2 square. And then multiply the exponents 3 times 4x. And then here multiply the exponent. And things are equal. When the bases are equal, then the exponents are equal. Right, multiply them out. So x equal to 4x minus 6. Move the x to one side. And divide by 8. We have negative 3 over 4, right? So, to check to make sure it works. And then we have 8 to the 4x. Right, so we have that. Then 4 to the 2x minus 3. Right. So that is the first type of exponential equation where we bring both sides to the same basis. When the bases are the same, the exponents must be the same. Next, where we cannot change that turn up to the same basis. So in that case, what can we do? Well, that we can look at the last property we have here for the log. And we can take the log on both sides In that case, let me just write the formula. Let's take the log on both sides. Logarithms. Usually we can use any log of any base. I prefer to use ln. Right. Then we use the properties over there. We can take the exponents outside. So here we have x times ln of 5 equal to x plus 2 times ln of 3. So this we take the ln of both sides, so we can take the exponent down. That's the purpose of taking the log on both sides, so the exponent will come down. Right? By the way, whatever you do, ln of 5 together is 1 unit. It's not ln and 5, it's ln of 5. And ln of 5 is 1 unit, or ln of 3 is a number. Ln of 5, we don't have the ln by itself, doesn't mean anything. So this is 1 unit. What we do now is distribute the ln of 3 into this, and we have x times ln of 5 equal to x times ln of 3 plus 2 times ln of 3. So here we have one number, and one number. So the goal is so for x, so I subtract x times the ln of 3, so we'll move x to one side. So you have x ln of 5 minus x ln of 3 equal to 2 ln of 3. And I can factor out the x. And here we just divide by ln of 3 minus ln of 5 on both sides. So if we divide by the parentheses on both sides, whatever that is, so we should have x equal to 2 ln of 3 divided by ln of 5 minus ln of 3. Right, so that is the answer. So in this case, I'll test that as well. 2 ln of 3 divided by ln of 5 minus ln of 3. Right, let's do that again. This time store into x. So 5 to that power, that's what we have, and then 3 to that power plus 2. Right. Next we have 3 to the 5x minus 6, and then 2 to the 4x plus 1. Right, once again, 3 and 2, there's both of them are prime. There's no way we can convert them to the same basis. So we can take the log. I use ln. Actually, we can use anything else, any other base. Actually, if we just take the any log of any base, let's say if we use log of base 3, for example, make sure you do that both sides though. And then we have 3 to the 5x minus 6. So the purpose of that is log base 3 and 3 cancel out. We just have 5x minus 6 equal to that. And then here we still bring the power down. Yeah, so that certainly works. But we have the log base 3 of 2. But like I said, I usually prefer to use the ln of x, because that ln, the way it looks will be on the same level. And then for the log, there's kind of the g. Anyway, only 2 letters. Certainly. we only need to write ln, 2 letters, right? So same properties, we take the exponent, add it down. Right, here we can multiply it out. So we have 5x, ln of 5 minus 6, ln of 5 equal to 4x, ln of 2 plus ln of 2. Right, now we subtract. So we have x on one side and move that to the other side. Right, so we have this 5x, ln of 5 minus 4x, ln of 2, and that cancel, ln of 2 plus 6, ln of 5. Now we solve for x, so we can factor out the x, and then we just have 5 ln of 5 minus 4 ln of 2 and then divide by the parentheses on both sides. This we have ln of 2 plus 6 ln of 5 over 5 ln of 5 minus 4 ln of 2. Right, so fraction ln of 2 plus 6 ln of 5 divided by 5 ln of 5 minus 4 ln of 2 store into x, and then we have 3 to 5x minus 6, or 2 to the 4x plus 1. Alright, there's something off. Alright, check. We enter x. Correctly. Right. Yeah, this is the obvious typo, sorry. For some weird reason I write ln of 5. Should be ln of 3. Right, that's why we check the answer, right? Right, let's try this again. Right, and then we have, when we just highlight, copy and paste, sorry about that. Right, next we have this problem. By the way, that look familiar to what we have before, and that's exactly what it is. We know the answer is negative 3 over 4. Now this one we just make sure we have that, but this time assume that we don't see it right away. Just jump right ahead and check ln on both sides. That certainly works. And take the exponent on both sides. So 4x ln of 8 equal to 2x minus 3 times ln of 4. Well, multiply it out. To x ln of 4 minus 3 ln of 4. We can move the x on one side. Right. Now, here we can factor out the x because that's what we solved for. For ln of 8 minus 2 ln of 4. And then we divide by the parentheses. For ln of 8 minus 2 ln of 4 negative 3 ln of 4. And we said this is a, how do we get 4? I mean negative 3 over 4 from here. Well, by the way, that is the answer. If we want to simplify this to negative 3, 4, so like what we have earlier, certainly we can certainly do that. So first, negative 3 ln of 4. If we want to, we can just leave it like that. Right. So what we can do here, we can combine the ln at the bottom. Once again, we still use the formulas that I highlight over there. This time, take the 4 inside, the 2 inside. If we want to, take the negative 3 inside as well. But let's see what we have at the denominator first. So we have ln a to the 4th minus ln 4 squared. Right. What's a to the 4th power? 4096. Yeah, we don't know what happened at the bottom yet. 4096 minus ln of 4 squared, 16. So next we use the property right above it. We subtract the log, so we will divide them. 4096 divided by 16. 256. By the way, we can change to the base 4, but let's say if we don't know that, we can say ln of 2 square. And 256, if we write that, will be to the 8th power. Right. Next we multiply it. We take the exponent down. So just take it to the same level. So we have times 2 times ln of 2 and then 8 ln of 2. I mean ln of 2, where we can cancel the ln of 2. Negative 6 over 8 or negative 3 over 4. Right, because that is exactly what we had before. So there's nothing wrong with taking ln on both sides, but it may take a long while to get to the answer. So if we don't know what to do, to take ln on both sides certainly works. Make sure that we might simplify the answer. might need to do that. Right, so the point here is try to convert them into the same basis so the exponent will be the same. If it doesn't work, try to take the ln on both sides, or try to take the log on both sides. I usually use the ln. Right, the third type of exponential equation that we study is something in this form, and which will require substitution. So here, notice that if I use u equal to e to the x, right, then I square both sides. We have e to the, give us e to the 2x. Now that's exactly what we have here, e to the 2x and e to the x. So the equation becomes u squared plus 5u minus 36 equal to 0. Right. So here we can just factor, multiply to negative 36. So that's like we have u plus 9 and then u minus 4. Right. And then we just have u plus 9 equal to 0, or u minus 4 equal to 0. And that gives us u equal to negative 9, or u equal to 4. Right. Now u is e to the x. So I substitute back e to the x for u, and now we solve for x. Now to solve for x, e, this is base e, and there's no way we can get them to the same base, so we just take ln on both sides. And there's a problem here. Right. So we can certainly take the x down. Right. This one is undefined, by the way. So, and then ln of e, that's properties that just cancel out. So I have x equal to ln of negative 9. It is undefined. As you see, it's not the real answer. So why is that? So when we use the substitution, we have u equal to e to the x, and e to the x the function look like that, and it have to be positive. So u is going to be positive, and we have negative 9 here. So that's why from here we should not get any solution from there. Right? We have the solution here though. We take ln on both sides. And take the x down. And cancel the ln of e. So x equal to ln of 4. So if we want to test our answer, we take ln of 4, store into x, and then we just have e second ln to the 2x plus 5. 5 times e to the x. We can just do e to the x. That certainly works. Minus 36. Right. So that's what we have. So make sure when we do the substitution on the exponential, cannot be negative. Right. Talking of not negative is what we solve for next. Logarithmic equation. The first type, if we have the log on both sides, log base b, log base b, if log of the same basis on both sides, that cancel out, the arguments will be the same. Just make sure whatever it is, the argument of the log must be positive. Otherwise, we have log of the negative numbers undefined. Right, so look at this. First one is obvious. Log base 2 cancel out. So two things are equal. The logs are equal. I mean the basis of the logs are equal. Then the argument of the log will be the same. So we have 2x minus 4 equal to x plus 2. Subtract x on both sides. We have 2x and plus 4 on both sides equal to 6. So x equal to 3. Now if we put 3 in here, 3 times 3 minus 4 is 5. 3 plus 2 is also 5. So this is equal. We'll just check mentally to that equation. So that's what we have. Right? But all of this problem, just make sure we check, because we do have to make sure that all the argument are positive. Right, so that's certainly positive here. It is actually 5, but we just check to make sure that they're positive. So that is our answer. Right, next we're trying to solve this. So we have ln. So logs are everywhere. So when the logs are everywhere, we try to get one log on the left side, one log on the right side. They cancel, and we have the arguments being equal. Right. So we do need one log on the left, one log on the right. So in that case, we use these properties so we can combine the log. In this case, the ln, which is the base e, so we combine them, turn into a product. All right. Now, the log on both sides, ln on both sides, just cancel out. If we have x minus 4 times x equal to x plus 6, multiply them out. X squared minus 4x equal to x plus 6. Now try to move everything on one side because we have quadratic equation in this case. X squared minus 5x minus 6 equal to 0. Right, to multiply to negative 6 and add to 5, negative 5. So it must be x minus 6 and x plus 1 equal to 0. So x minus 6 equal to 0, or x plus 1 equal to 0. So here we have x equal to 6 or x equal to negative 1. Just for all the logarithmic equation, just make sure we need to check the answer. This one we definitely have to make sure that we only have positive inside the log, because log of a negative number is undefined. So we have 6 and negative 1. So for 6 minus 4 ln plus ln of 6 ln of 6 plus 6. So x equal to 6. So all we actually need to check is positive, positive, and positive. So that's good. By the way, that will be 2 and 6 and we can combine the log, so they indeed are the same. Now x equal to -1. If we put the -1 into it, right there we see it is negative already, so it's not going to work. So it's negative. Again, it's not going to work. So make sure for logarithmic equation, make sure the arguments must be positive. Right, so that is the first type where we have logs are everywhere. Make sure we have 1 on each side, so the log of the same basis. I cancel the exponent, the arguments of the log should be the same. The next type is where we convert to the exponential form. Right, so in this case, we not only we have logs everywhere, we have a constant, the number by itself. So we might have something like this. Let's say equal to a. Right. So we can convert to exponential form, which is base b of a, b to the a power equal to m. Right. So if we have logs everywhere, make sure we have 1 on each side, so that will cancel out. If we have log and then a number, convert that to exponential form. But at any event, we need to check our answer. Make sure whatever to substitute into the log must be positive. Make the argument positive. Right. Here we have a log and then the number. So definitely that's what we do. First, try to get the log by itself. And then we just swap to exponential form. The base is 3. And we just swap this to the 2 to this side, and the 2x minus 7 to the other side. That gives us 9 equal to 2x minus 7 plus 7 on both sides, and divide by 2. So divide by 2 on both sides. We have x equal to 8. Now, remember, every logarithmic equation, we need to check our answer. This time we have 8. Substitute into x. And this indeed is positive. Of course, if we want to check, it's very easy. We have 8. So for log base 3, if we want to enter that, it's under math. Yeah, if we cannot type that, we can use the chain of bases. Just want to do this so we review the chain of bases. Sorry, not that. 4 times. If we cannot type the base 3, use the chain of bases and type, use ln of 2x minus 7, ln of the argument over ln of the base. We should get the same thing. Right, so that is the chain of bases formula. Right, so in this case, that's what we have. What we have next here is log base 2 of x equal to 3 minus log base 2 of x minus 2. So we have the logs here, the logs there, but there's a constant. Every time there's a constant, we need to convert into this, and then so we can swap to exponential form. So first, I'm going to move that to the other side. So we have the number by itself, the log by itself. Right? So we have log base 2 of x plus log base 2 of x minus 2 equal to 3, and that cancel out, right? Now once again we use the properties that still highlighted and we combine them. If there's if there's a difference, then that will be that will be divided. Right? That's what we have. Just we write that as x squared minus 2x. I just multiply it out. And then a log equal to a number. We swap to exponential form, the base of 2, the 3 goes here, and x squared minus 2x goes there. 2 to the third power is 8. Subtract 8 on both sides. So x squared minus 2x minus 8. So x squared minus 2x minus 8 equal to 0. Right, this is easy. I can just factor. So x minus 4 equal to 0, or x plus 2 equal to 0, x equal to 4, x equal to negative 2, and make sure we check our answer. For x equal to 4, substitute 4 into x. So indeed we have positive here and positive here, so it's good. So we have the solution x equal to 4. How about negative 2? Well, we don't have to go very far on the first. The first one is negative already, so it's never not gonna work. So it's 4. Of course we can put 4 in and make sure that they are equal. And it should be equal, right? So if we have a number, we have to move all the log to one side and combine that into one big log, so we can swap to exponential form. The next equation, we have actually logs everywhere. This is actually the previous type. I'm not going to solve for this. What I just want to show you is for this equation we can use either way. Okay, first the log without the base, that's a common log, base 10, right? So we certainly can combine them, and we say log, we have x times x minus 8 and then cancel out the log, the arguments are equal, right? So that certainly works. Of course I'm not gonna do that, just gonna show you another way. So even though if that works and all, we can always move everything on one side. So just subtract that. In that case that will equal to 0. Now we combine all these logs. We have log x on the top, x minus 8 on the top because they are positive. The negative be at the bottom. Right? Now by equal to 0. Now by default, common log is base 10, and so from here we can swap this to exponential form, base 10. Uh, 10 to 0 powers is 1. So we certainly can do this to solve for x that way, because cross multiply and the rest. So bottom line is there's two types of equation. The first type where we have logs everywhere. Actually, this is what we have here. In that case, make sure we have 1 on this side. The log of the same basis cancel out. The argument will be the same. Or we have the log equal to a number. In that case, swap to exponential form. If we do this way, that will be more complicated, but it's not wrong. Right. And that's all I want to cover in this section 4.4. Thank you for watching, and see you in another video in course algebra.